Hi everyone. This video is meant to cover confidence intervals for a mean, that is to find or to estimate a population mean from sample data. Now when we use the sample data, in this case we have a sample of 40 patients, so just to start this off, we already know that we've got a sample, it says so, and that n is equal to 40, and these patients were tested for HDL cholesterol levels, and their mean level was 50.7. So when they say the mean level of 50.7, that is because it's from a sample, x bar is equal to 50.7. For the population mean, we use that crazy symbol mu, this guy right there. That stands for the population mean, there, which is usually different from a sample mean. Okay, so if we continue, we've got a sample of 40 patients tested for HDL cholesterol. They had a mean level, sample mean 50.7, and a standard deviation 11.85. So this 11.85 right there, that is the sample standard deviation S, 11.85, and that's the same S we see in the formula down below. The last thing we need to know is, well, what we're supposed to find, which is the 95% confidence interval for the population mean for the HDL cholesterol level. So we will also know that we want to have a 95% confidence interval. Okay, so now where do we start? We already know that the sample size is 40. We know that the sample mean is 50.7 and the sample standard deviation is 11.85. And we know we want a 95% confidence interval. So if we look down here at the formulas, we need to know, first of all, that this has a roughly bell-shaped distribution. And then we have to find a lower bound x bar minus e and an upper bound x bar plus e. And the error is this formula right here with the n minus 1 degrees of freedom is how we find T alpha over 2. Okay, so we have all the basic information, but now we've got to find the T alpha over 2 that we need. Now our n is equal to 40, which tells us that the degrees of freedom is 40 minus 1, which is equal to 39. Now that's the row that we will look at in Table 6. We also know that we want a 95% confidence interval, which tells me that we have 5% left over. Let's say left over for the two tails, which means we need to have 0.025 in the right tail. And that's the column that we're going to look at in the table. Okay, so let's go take a look at the column. Remember, we're looking for the row, 39, and the column is 0.025. All right, now let's flip over and look at the table. Okay, so here's the table. So we're looking in the row 39, so I'm going to scroll down to 39 here. 39 is right here. Here's the row for 39 going across there. And we want the column to be 0.025. So this is the column we're looking at for a 95% confidence interval. And we're just going to go down this column and see where they cross, and where they cross right here at 2.023, that is our T alpha over 2. And get it right there. Okay, now let's go back to the other page and we'll continue. Okay, so we know T alpha over 2 is 2.023, and that comes from the table. Okay, so now we can use the error formula right here. The error is equal to T alpha over 2, 2.023 times S, which we found to be 11.85, divided by the square root of the sample size, which is equal to 40. Okay, so now to do the order of operations here, we would do the square root of 40 first, divide that into 11.85, so it'd be 2.023 times, and if you do 11.85 divided by the square root of 40, you get 1.873 649, so I'm going to call that a 5. And then you multiply that by 2.023, and your margin of error turns out to be 3.79 rounded off. All right, so that's our margin of error. And that's it right there. Okay, so now how do we use it? Right back over here, we have to do the lower bound and the upper bound, where we take the sample mean and we add and subtract the margin of error. So our lower bound is going to be the sample mean. And the sample mean was what again? Where was that? Oh, right, 50.7. So 50.7 minus 3.79. And the upper bound would be equal to 50.7 plus 3.79. So the lower bound turns out to be 46.91, and the upper bound turns out to be 54.49. And now we have to summarize. So let's change colors and summarize. Summary. So every summary has to include how confident you are and what's the interval. So we are 95% confident that the mean HDL cholesterol level is between, it's always got to be an interval, so it has to be between, in this case, 46.91 and 54.49. So that's apparently what we'd expect to see in HDL cholesterol levels for the entire population, at least of the patients who were tested. Okay, please let me know if you have any questions, and hopefully this will help you be able to solve some of the problems that you will find in the homework. Thanks. Bye.